Hi there, I'm Johannes, and if you're wondering, this was just a merge conflict virtually. I will be talking today about how you write your own Java profile in 240 lines of pure Java. Without further ado, I want to take you on a small journey. You probably all know when you come to an event and we help to organize it, and the people are like, "Hey, aren't you a computer scientist? Can you write us some software code?" And I was in the same situation. So I was organizing with some others event similar to like a conference where professors could present their research at my hometown's university, and it was the Corona time, so we wanted to have some interaction without real interaction because of course Corona. So one of the ideas was we wanted to have an app where we could ask people questions. For example, we would ask, how old is the universe after an astronomy talk, and the people could answer with some estimate, and then in the end they would get a prize if they were the most correct in the bunch. And they asked me, "Hey, you're doing this, you're a computer scientist, you should know this." And I'm like, I did my master's, I started a PhD, I know how to write web applications, of course I know. So what you see, I wrote a basic application because we expected like 100, 200 people, so it was like, keep it simple, keep it fast. We had a client application where people could answer these questions, and we had an admin interface where the admin could set a question. And on the server side, we're just a simple server. I didn't want to use a database because it seemed to be overkill. So I just stored all data in a JSON file, and that went for. And then in the testing, it went well. So yeah, it was good. And the client was regularly requesting, like every 10 seconds, whether there is a question. If yes, displayed it. And so, because I did this, because I thought like pre-merge optimization is the root of all evil, according to Donald Wolf, and I'm like, yes, I didn't pre-mergely optimize. And then the event came. Any guesses what happened? Any? Yes, of course it crashed, because the server was overwhelmed, and the thing was, we were doing this not live, but we were like, all the presenters were like in one venue, and so I sat there the whole evening restarting my server, so it dropped the connections to the client. It was quite funny and embarrassing, but because I mistakenly forgot like the larger picture of Don Knuth's talk, of Don Knuth's quote, he wrote, "We should forget about small efficiencies, about 97% of the time. Pre-merge optimization is the root of all evil. Yet we should not pass up our critical opportunities in the critical 3%. A good programmer will not be lulled into complacency by such reasoning. He will be wise to look carefully at the critical code, but only after that code had been identified." So how do we identify it? Profiles to the rescue, yay! When I talk with people on the street or friends that aren't computer scientists about profiling, they were like, "Are you someone like Sherlock Holmes, solving crime scenes? Or are you, we're here in Belgium, are you someone like Hercule Poirot, solving crimes on the Orient Express?" And I'm like, yes, because we have a crime scene, of course. My software was overwhelmed, and we need to search the culprit. Nowadays, in software, we can just use git blame and see actually a person who did something wrong, but it was my software, so I was to blame anyways. So a quite useful tool for visualizing flame graphs, for visualizing performance data are flame graphs. So on the bottom, you see the bar that represents the relative amount of time related to the whole program runtime that each method took. So here, the main method took all time, and on the top, you see the pseudocode of the application. So the main method did some setup of the server and called then the server loop method. And then this server loop just got every time a new request and then checked, hey, is this a question request? And if yes, send a question request. And as we had many, many more clients than servers, so this was the method that was called most often, and you see it reflected in the flame graph. And then what did send question request do? It called current question, so it checked is there a question enabled and then returned the current question. And any guesses what both methods spent most of the time working in or doing? Yes, of course, I.O. They were parsing JSON, they were loading this file, and it was horrible. And I saw this flame graph, and I was like, I like frame graphs. When you do something stupid, it punches you in your face, and it's impossible not to see it. I have the second Mario Fusco there. So when I then replaced it by like a tiny database, by like an SQLite, I didn't need a large database because we didn't have too many participants after all. It went smooth, but the problem is now we don't use it anymore because Corona is over and the people come to our venues directly. But that's, you see, profiles are really valuable part of your toolbox of coding techniques. It belongs to a toolbox like debugging because you need debugging to fix like the bugs in there. You need poly testing also, and you need load tests for such applications. And then in the end, when you found a problem, you probably want to use profiling and also look into the performance implications to shine light on your performance problems that you have. Who am I to talk to you about this whole stuff? I'm Johannes Bechberger. I work at the Submachine team. It's one of the many great open source projects at SAP. I sometimes speak about profilers at conferences, as you see there. And I have stickers in the front. I have a limited number there with the yellow submarine, so come quick after the talk. So what do I do for work besides like being at conferences or speaking to you on the importance of profiling? I'm working on my own profiling frontend based on Firefox Profiler. I'm working on profilers like Async Profiler and also a new API for walking stacks, a new profiling API for the OpenJDK. So who of you used the profiler before? That's a lot. What I found interesting that this is even more than like the JetBrains 2022 survey, but we probably have some selection bias because one speaker told me like, yeah, when he asked this question like 5 years ago, almost nobody held their hands up. So it's great that more people are interested in this field. So what is profiling for the few people here that don't know? According to a definition from the jargon file, it's the obtaining a report of the amounts of time spent in each routine of a program used to find and tune away the hotspots in it. So that's essentially what we're doing. But we're also collecting more data, but the method profiling data is like usually really important. And we're focusing in this talk on this data. So before and go deeper into like writing your own profiler, I have to tell you about the two main types of profilers. There are instrumenting profilers and there are sampling profilers. Instrumenting profilers are like the most basic ones. So, for example, here you have the server loop method from before, and usually when you want to know, so how long did this method take, you would take the time at the beginning of the method, print the elapsed time at the end of the method, and then you know how much time this method took. We can automate this because we have like Java agents. They can instrument your code automatically on ClassLoad to add such instructions directly in. So it's really done automatically. You don't have to do anything. Main problem is you're not profiling the code that's really running in production. You modify the code. The JIT doesn't really like it because it has more to do. It might have effects on garbage collection and such. So it's good if you want to know like the precise invocation of every method, but it's not good to get like a realistic picture. And contrary to this, sampling profiles just ask the JVM in regular intervals, like every 10 to 20 milliseconds, what are you currently executing? So they poke the JVM. Like, give us this information. And between these intervals, we don't know what the JVM is executing, but we are like, approximation is good. We get enough data. It works in practice quite well, and so most of the currently used profiles are based on sampling profiling. And the cool thing is, the profile code is actually your production code, so there is no added stuff here in your method. You're really executing the method and profiling the method that you executed. And that's really cool. And that's why I want to show you that they aren't rocket science. Who of you created his or her own profile before? Oh, 4 people. That's more than I expected. So that's cool. Keep up the good work. I did this too because I thought like I wanna show people that profiles aren't scary. And so I wrote my own and wrote a blog post on it. You can find this the blog post under this URL with the QR code. The funny thing is, I gave the same talk in Milan this year, and after the conference, after the user group, someone came up to me and said like, hey, I want to use this in production, because he was at a consultancy firm and he was like, I cannot attach a profile at runtime, but I can just copy your code because it's MIT licensed on GitHub, insert it in our client's code, and we're fine. We have profiles in there now. And I was like, okay. So be aware that when you put something with no license on the internet, people will use it in ways you never expected. So yay. Anyways, let's start about our own. So the basic concept is that we attach our profiler at runtime as an agent, so it runs alongside our application. So we have, of course, a main class. This is the main method. There's some option parsing. Then we have the profiler. This is started by the main methods, and what the profiler does, it's a sampling profile, so it essentially samples, so asks the JVM, hey, what are you currently executing, then sleeps, and then samples, and sleeps, and so on. And it generates some data, and what does it do with this data? It stores this data in not a database, but in an optimized data structure, which it uses to later create the flame graphs that we've seen before. So now to the main class. So the idea is that we use this profiler by passing it via -Java agent as an option, and we can also pass it some options like the interval. And so the interesting thing is you can either attach it like at the start, or you can attach the agent like later, and it both works also with this profiler. So when you attach it later, the JVM calls the agent main method, and when you call it directly at the start, it calls the pre-main method. That's cool to know, so you know when you're executed, and you can deal differently. So the main class itself mostly just parses the option as you see there, and then runs it. So we have to run the profile alongside our application, so we essentially create a thread for it, and then we tell the JVM, hey, please, it's a daemon, because the application shouldn't like run forever because we have a bug in our profiler code. So the daemon means that like the application stops and ignores the profiler thread, and then we name it. Please name your custom threads. It's such a help with debugging if there's a proper name in there. And also your users, when you ever do this as a tool developer, please do this. And then we start the thread, and yeah, our profiler sample sleeps. And when we create a new instance, we also register a shutdown hook. And the shutdown hook is a cool thing in Java because it essentially allows us to tell the JVM, hey, please, whenever the JVM ends, whenever you end this application, please also execute this other code. And essentially, profiler on end stops the profile itself and prints like the method table and stores the flame graph. And then it returns the profiler. But be aware that there is subtleties in like concurrency and everything. So it's an interesting topic there. So it might look easy, but there's some subtleties. So you see some volatile sprinkled in my code therefore. And what does the sample then do? Or how do we get a sample? There are, when we're on the native level, when we're writing C++ agents, we can use async call trace, so we can directly ask the JVM for a certain thread what it's executing. But here we only can access like the get all stack traces method. to access all stack traces. The problem here is that JVM has no way to give us all threads that are currently executing. So we have to ask it for all threads and stack traces, and we get these stack traces. Essentially what we're doing then with these stack traces, we check whether they are daemon threads, because essentially it's a shortcut to checking whether it's our own profiler, and we don't want to store it there. And then we add the sample to our store. A stack trace consists of different elements. So essentially, the stack trace is the thing that you get when you throw an exception, and you see it on the command, and you see it like in your editor. And every element contains the information on the class, on the methods, on the line number where the exception occurred, and also like on the exception class itself. But here we don't have an exception class, so. And then we store it somewhere. And we, in the end, would like to have flame graphs because they're quite nice, they are short, they're good to show in conferences like this one. And so essentially, what we're doing, we know that every part of the flame graph corresponds to different stack traces. For example, here in this example, we know that somewhere in the program's execution, we have a main method that called a server loop, that called handle question request, that called a current question, that called a pass JSON. So we use those stack traces that we obtain from sampling. And what we do, we create a tree, because computer scientists like trees. They're easy, they're memory efficient, we can work with them. So every tree knows the method that it belongs to, and also has a hit count. So how many times did this occur? How many samples did this occur in? So the main method, we ask the main node, hey, do we have a child called server loop? And it's no, so we create one with a hit count 1. We do this with handle question request, current question, and also pass JSON. So then we're back, we're seeing another trace. That's this time similar, so we increment the hit count for every node. So then we have a new stack trace where the top frame is missing and the thing goes on, but here all nodes besides the topmost node get an incremented hit. And then we have a whole another different stack trace where we have is question nail on top. So we branch it, and we do this over and over and over again until we have finished our program, and then we can turn this back into a flame graph. It's quite easy. We know that like the maximum width, maximum amount of hits is 4, and we split our bar into 4. We know main has 4, server loop has 4, and question request has 4, current question has 3, is question enabled has 1, pass JSON has 2, and pass JSON there has also 2. So that's cool. I hope you now understand flame graphs, even those of you who haven't written your own profiles. You should really do. Write one in C++ or .NET or in Python. It's a quite nice thing to do, and you learn a lot in the process. And then, of course, I could have written my own flame graph generation, but if we're honest, who of us wants to write lots of JavaScript codes? I just use the D3 flame graph library. And if I'm honest, the title was a lie. So the problem was I put this blog post out, it went viral on Hacker News, and then someone in the comment section was like, you have a small concurrency bug. You have a small bug because like constructors have subtle differences. So in the end, it's 251 lines of code. I hope I didn't disappoint you, and you know, I hope no one of you came just in this talk to see I wrote one in 240, because like there's 42 in the name and it's special. Because you're so kind and don't run out of the building after I disappointed you, I tried my first live demo here on the conference. Yay! I hope someone burned some USB cables to make the demo codes happy. Yes, it works. So essentially, we need a test program, and I asked ChatGPT, and it was like, here's a Fibonacci function. And that's really the best Fibonacci function you can think about, the most performant implementation that computer science students learn. That's not a point. You see here the main method. That's quite simple. You see here the agent, main method, the pre-main method. Also, there's this options class here. This is also just generated. It parses these options. And there's no point in showing to you, but here you see it's just the code that they've shown you on the slides. And then there's the profile. It's slightly more complex, but in the end, it gives you also some information why it's not the best thing you do here with get or stack traces, but it's good enough for most cases. So yeah, not if you have like thousands of threads, but whoever has thousands of threads, especially with like Project Loom coming. So essentially here is then the store, and it's a simple tree generation. So we use this tree, we use then some HTML, we create it and write it down, and that's essentially our node that I showed you before. So it's really simple. You can download it from GitHub, hack on your own on it, and so if you want to use it, you can just run it, as I did before. Yeah, you see that Java has long method names. Here you go. What I did here, I called it with Java and then minus Java agent. So I'm directly executing the fib.java class. That's possible since I think it's JDK 17 or so, and that's quite nice. And you see here that most of the time is spent in some main method, but then 57% of the time is spent in the fib method. Keep in mind that when I say time spent, it's not real time spent because we're sampling. We don't know whether the method between these calls, in between the intervals, was just dormant, lying there, was executing something else, but we're getting a good picture. So you can usually say it's approximately the time, but it's more specific. It's the amount of samples, and then it created a file. Here it is. So we can see the flame graph, and we can see that the Fibonacci function is called quite often and has a deep stack. And we also can do other things. For example, we have here the Java C compilation threads that were doing the compilation before. We can see here what the Java compiler does when it compiles your Java application, when you pass it directly on the command line. It's quite interesting code. You can dive into it and see whether there's something interesting. When I dived into it a couple of days before, I found out that sometimes it's not really beneficial to do this, because you see here we're essentially half the time spending in our compilation stuff. So pre-compilation is cool. They don't mean the crawl-VM stuff pre-compilation, but also that you can ask Java C. So before you actually execute the program to run it, it's quite cool. And then back to our slides. So in reality, we aren't using this. I hope we are all sure, except some Milanese consultants. If you're out there, thank you for using it, showing the world that we can profile with a couple of lines of code. But in reality, we're using a few different sampling profiles. So they're, on the one hand, external sampling profiles, and on the other hand, built-in. The external ones are attached externally to your JVM, and are developed usually by different developers than the OpenJDK. The built-in ones are developed by the internal OpenJDK, by the OpenJDK maintainers. So with the externals, you have synchronous and asynchronous ones. The synchronous means that you ask the JVM, hey, please give me the stack trace, and it only gives you the stack trace when it's ready. For example, when it's in a safe state at the end of a method or in between ends of loops or so. So that's has the advantage that it's a bit safer and that you get slightly more precise data. But the problem is you're only getting it at certain points in the execution. And then you have asynchronous ones. They ask the JVM, and they don't care whether the JVM is in a specific safe state. They just want to get the data. So they are slightly more accurate. give you a slightly more precise picture of the performance situation. So with the synchronous ones, one of the most famous is like VisualVM. It was also embedded in NetBeans before, and it was famous because like it was usable for free since like the 2010s. And that's also the first profiler that I ever used when I was a student. And then there's the asynchronous ones. So the idea is here that in 1991, like in the olden days, people started working on further analyzer even before Java was created, and people started at Sun working on a profiling tool for different language runtimes. And in 2002, they wanted to have proper support for Java, so they added a async get call trace call. But then, like, they removed it 3 months later, and ever since it's still present there. You can use it via DL. It's not present in any header, but you can use it via some C magic to get access to it. And then, like in the 2010s, people started using it, and nowadays it's mostly used by async profiler, which is like the building block for all major profiling solutions out there that are like not the standalone profiles, but like your application performance monitors and so on. With the built-in ones, we have the Java, and then later it was called JDK Flight Recorder, and it's built in. It gives you lots of data, and it has also a front end that's called JDK Mission Control, and it was created like in 2012. It was added to Java before it was like created as an internal tool by JRocket. And then in 2018, it was open sourced. And the combination of both JFR and async profile is used in most of the kernel applications that do your profiling. So even if you don't know whether you use async profile, you probably use it when you do any data monitoring or performance monitoring out there. But please take these profiles with a grain of salt. There are many great engineers in the OpenJDK are working on it, but still there are bugs in it. It's like your own application. Your own application probably at your company could have more tests, certainly more than one, which is in parts of the OpenJDK for our profile, for our core profile method. So it could have more tests, it could more documentation, I think. But the profiles are usually right. Just keep in mind that also profiles can have bugs. If you find such a bug, come to your favorite OpenJDK developer out there, tell him this, and he can work on it, or relay to me, because I'm the person who did a few bugs in the last couple of years. Fix them. So after this, after you know how to write your own, and know what types there are in profiles, you probably want to know how you can use these. So to obtain a profile, you can, with async profiler, you just pass like the async profile agent via -agent path to it and tell it to start, and then also to tell which event to listen. So you have to know that the interval is relative to specific events. So you have the CPU time, you have your world clock time, intervals, and so you can choose them, and then you can tell async profile, hey, please output a flame graph, or also please output a JFR file, output JDK Flight Recorder file, because that's like the standard format for profiling data in the OpenJDK. And what's cool, you can also tell async profiler, hey, please run JFR alongside, take the things that async profile can do good, take the things that JFR can do good, merge it, and you're fine. And that's usually what I would recommend to people. And then there's the JDK Flight Recorder, which you can start in newer versions, so since JDK 12 with start flight recording, and then just pass it a name. And then in older versions, you had to enable this feature. And also the two things that appear now are some options that you usually want to pass. They have negligible performance impact, but they just increase the accuracy of your profiling. If you want to know more about like async profiler, there are some cool resources out there, and also for JDK Flight Recorder. At the end of my slides, I'll have a QR code that you can scan, and it goes and it gives you a list of literature on the web page that I created. The cool thing with like async profiler, it also works on OpenJ9, but it doesn't work with Windows. So JDK Flight Recorder works on Windows, which is really good because all of you are probably using Windows on your cloud systems in production. Hopefully, at least we don't. So. At least I've never seen it much. So usually it's the Windows support is not important for async profile use. So yeah. What's cool with async profile and also JK Flight Recorder, you can both attach them and detach them at runtime. That's especially important when you have a running system and you want to like start a recording in the middle of your run because you experience some performance issues. And keep in mind, there are some file sizes, and the files that you generate can be quite large, so you want to limit the time of your profiling to really the time you really need, because like gigabytes of data on your hard drive that create in a cloud setting. The cool thing with JFR especially is that it allows you to create so many events. So there's so many events, there are like 120 events that I created a website there at submachine.io/JFR events, where you can look these events up. So for example, you can get data on all the GC, on all the garbage collection parcels. You can also, if you want to scratch that itch, as a compiler engineer, I'm one by heart, so I will like also events like compiler inlining, where the compiler tells you, hey, I wanted to inline this method in this other method, and it worked, yay. And you can also see like where this event is supported. For example, here you see that the callee property was only into the callee property has a different like type. Here it's a struct, and you can also see with some properties when they were created. If you want to know more, this QR code goes you just straight there. Be aware that there isn't that much documentation on JFR events, because usually the answer by people is, when I ask them, is like, look into the source code. So if you want to contribute, please feel free. The OpenJDK is an open source project, so feel free to do this. But now, consider another setting here. We hear the conference where many people are talking about their cloud software, and consider now we're creating our own cloud service called Math as a Service. We use the best algorithms generated by GitHub Copilot to generate you, for example, Fibonacci methods. Fibonacci numbers. And for example, here via this URL you see below, we advertise that you can get the nth Fibonacci number because you want to get the freshest and best Fibonacci numbers created by the slowest algorithms that we can find. So essentially, we want to do some customer analytics, and we want to see how long it took for a customer to create the nth Fibonacci number. So essentially, we could store this in like your Prometheus database, so on, but we can also just store this information in our JFR data, because the advantage is that we then can use normal JFR viewers to view this data. So here, how do we create an event? We just extend the class jdk.jfr.event. And we create two properties. One is called session ID, one is called n and Fibonacci number, and then we just add a constructor. I omitted it here because it just literally just sets the session ID and the n. Then how do we use it? Here in this example, before we compute the Fibonacci number, we create the event and call it begin. So we associate the event with a stack trace and also with start time. Then we compute the Fibonacci number, print it out on our web service, and then we call commit. So this means we store it back and also add to this event a duration, so we know how long it took. And so it's really just this. So it's just that simple. And if you don't believe me, there's the code, and it kind of it works. And here's the main class that does this. And here we created, and this really worked. And then when you do this, you can go into your favorite JFR file viewer and get information on it. For example, you see here that the computer 37th Fibonacci number it took also for like 67 milliseconds. You see the stack trace, and it's cool because you can then use like the same tools and you don't have to set up a Grafana database or so. So here you can then want to, of course, inspect the profile. I've shown you like how you can, how you can see custom events, but of course you can also see your own method sample events. So one of the most common tools is Flamecast, but I've covered them before. So here I'm focusing on the two other tools. The most used tool in the OpenJDK world, like the big open source tool here, is the JDK Mission Control. It's related to JDK Flight Recorder, so it can only view JFR data, but as this is like the default data for Java profiling, that's okay. So this tool is based on Eclipse, and it gives you a lot of information. So it has a steep learning curve to get to grips with it, but if you do, you can really get a lot of information out of it. For example, here you can see some statistics, some overall summary on the performance. You can see some flame graphs for method profiling. They are upside down, and don't read too much into the colors. They are related to the packages in which these methods appear. So that's just to keep in mind. And also you can get some information on the memory consumptions. Where is the most memory allocated? You can get some information on the garbage collection, because that's actually useful when you want to see, is my current garbage collector that I'm using working? Does it need more memory? Should I use a different one? You can use this view. But then it's quite hard to use, especially for a beginner. I would certainly recommend trying to use it and get to grips with it. Take like 2 or 3 hours to play around with it. But last August, I was in the situation that I wanted to profile an application related to debugging, but I didn't have a proper profiling solution. I was like, I can write it on my own. So I started to work on it, and that's the result here. It's the first open source profiling plugin for IntelliJ. It's still a prototype, but you can use it. You can download it from the JetBrains marketplace. And to profile an application, for example here, of Fibonacci generating code, you can right-click on the method like you do when you want to debug something, and tell it, hey, please profile it with JFR, and also tell it profile it with async profile, support both, and then you can get, and then profiles it, and up pops a file viewer, so you can open all JFR files if they aren't too large. And yeah, you can see some information. You can see the method tree. You can even click on the method and jump back to your source code and view the source code. So here you directly see which lines are hit the most. So at each line you see how many times it was hit, which is really cool. It's based on Firefox profiles. I didn't write all the UI myself. The Firefox profile is really great and also to extend it. So I use this, and we have flame graphs, of course, with more information on it. For example, we see how many of these methods were JIT compiled at the time. This can help to optimize our code. And also, of course, as I showed you before, we can see the different events. You might be wondering what the impact of performance is, and that's a valid concern because especially when we're profiling in production, that's really valid when you're profiling, and this makes our application far slower. Then why are we profiling? Then the simplest solution would just be disable the profiling and get like 20% more performance out of it. But usually, at least according to literature, my own experiments, the JFR with like reduced setting, this meant for monitoring, has an overhead between like 0 and 5%, but it's typically lower than 2%. And when you extend it, when you tell JFR, please profile everything, so almost everything, it goes up to like till 8%. And with async profiler, it's in a similar ballpark. So the literature, so people in the literature tell us so that usually perform production is usually below 2%. In some cases, it could be up to 6%. And then when you combine both, of course, when you combine JFR and async profile, you get like the performance hit of both. But also keep in mind that the file size is important. So with the JFR profiling setting, you're creating lots of data, which might be problematic. So keep an eye on this. Because this data shouldn't probably accumulate on your cloud servers, because memory is sometimes quite expensive there. You might want to do continuous profiling. The easiest thing is to just tell async profile like, hey, please create a JFR file every like 1 minute and store it back, and then you can use like rsync to copy it away. And that works, but it's kind of just like a small bash script, so it's not too advanced. More advanced solutions are solutions like Pyroscope. Pyroscope gives you a profiling solution where you can run the Pyroscope agent on your system, and it gives you also flame graphs and advanced data. And you can work with this to get more information and to like view it and analyze UI. And there are of course many other tools, like for example Parker, that you can use to work on this. And so these tools like continuous profiling, also like profiles that you use to profile your application that is running on your system, should really belong to your toolbox. So it should belong to your toolbox like debugging, like testing. And you want to learn it before you have the incident, because when you have like an incident and your customer is like, the application is really slow, we're having problems, and you start by like reading your manual and being like, oh, what should I do? It's probably too late. So I would recommend getting a glimpse on these tools. There are many other great talks at this conference that might help, and I would recommend you, if you haven't seen them, go to the videos, see them, just to get like an idea of what you can do. I'm Johannes Bechberger again. You can find me on Twitter. You can find me also on GitHub. I'm regularly writing on my blog, mostly nerdless.de, on topics like in-depth profiling and debugging topics. And you find my team, and we're like the 3rd biggest OpenJK contributor at Sweet Submachine. For example, what we did, one of our colleagues implemented helpful null pointer exceptions that came like a few years ago, and he's also maintaining JDK 17. So it's really great to be in this community. So yeah, if you have any questions, feel free. Any question? Yes.
You mentioned a few times that you use it also in production.
So I myself don't use it because I'm a profile writer, but many people use these profiles in production, yes. So it's not uncommon to attach them in production, especially if you use application performance monitors. There's, for example, one from Elasticsearch that you can attach, and this uses the profiling under the hood. That depends. For example, JFR works on, as far as I know, but there's a JDK developer that knows far more than I in the audience who can correct me. But it works on all, JFR works on all platforms. Async Profile only works on a limited set of platforms, just on the biggest ones, because maintaining a profile on all platforms is quite a lot of work. Oh, so with flame graph, so the question was how when I sample randomly, how do I ensure that the flame graph entries are in the right order? They are just ordered by like the alphabet. They are not ordered by time, because in flame graphs you usually remove the time information. So that's not a problem. Any other? Yeah.
Do custom events show up in some reasonable way in mission control? Or do you
Yes, of course. I just hit the slide because I was running out of time, but you can open it in mission control and it appears like any other event too. So yes, every JFR viewer knows how to show this because they aren't distinct from other events. They're just there. Any other questions here? So then thank you for your audience. And here, if you have any more questions and if you want these nice submachine stickers with a yellow submarine on, just come in the front and grab you one. And have a nice conference. Thank you.